As we continue on our left-to-right tour of the bolster switches, we come to the wing and stab IPS system, which consists of pneumatic de-icer boots on the wing and tail leading edges. These inflate and deflate to crack and shed ice from those surfaces. The de-icers extend the full span-wise distance of the wing and tail from root to tip in order to provide maximum protection, and are separated into 3 zones which inflate individually: the tail, the top half of the wings, and the bottom half of the wings. The boots are inflated and deflated using engine bleed air extracted from a dedicated port, which is then routed through a heat exchanger for cooling. This bleed air is always in use, either to inflate the de-icers or to create a vacuum through Venturi action to hold them down when not in use. The system controller has 3 operating modes. When the wing stab IPS switch is off, vacuum is applied to keep the de-icers held tightly to the wing and tail surfaces. Turning the wing stab switch on causes the controller to automatically and continuously cycle 3 de-ice zones every 60 seconds. The tail inflates for 6 seconds, then deflates. The lower wing zone inflates for 6 seconds, then deflates. And finally, the upper wing zone does the same thing. After that, the system will pause, or dwell, for 42 seconds before starting the whole cycle over again. The final mode is referred to as single cycle mode and is activated by turning the wing stab IPS switch on and then off again within 24 seconds. This commands the system controller to run the 3 zones through a single cycle as previously described and then stop. The aircraft systems display contains a synoptic page for the ice protection system. The wing stab IPS is monitored by the avionics, and you'll be notified in the event of controller or pressure failure, high or low bleed air temperature, or any other malfunction. When using the de-ice boots, there are a few operational considerations to keep in mind. Full flap deployment is prohibited in icing conditions, and a CAS warning will advise you of this fact if you attempt to deploy the flaps 100% while the wing stab IPS is on and the temperature is 0 degrees Celsius or below. Not only will you receive this warning message, but the avionics system will prevent flap deployment beyond 50%. In addition, the avionics system will adjust the stall warning and protection system to a higher speed to compensate for icing conditions. Once you have shed all ice and no longer are in icing conditions, it's possible to reset the stall speed offset by pressing the IPS stall speed reset button located on the touchscreen controller. You will also need to keep in mind that the pneumatic de-icers have a minimum temperature of minus 40 degrees Celsius for activation. Below that temperature, the elasticity of the boot material is significantly reduced, and they may be damaged if inflated. You'll find that effectiveness of the de-icers may be reduced at airspeeds below 160 knots, resulting in larger and rougher ice shapes than normal. For this reason, 160 knots is the minimum speed for operations in icing conditions, so airspeed should be maintained above this whenever practical. It has been shown that early activation of the system reduces the size of initial ice shapes, so it's recommended that you do not wait for a certain level of ice to build up before activating the system. If you anticipate, suspect, or detect ice buildup on the airframe, turn the system on.